car tracking example code you gave us for the particle filter, I guess there wasn't, the PQ over Q step, there wasn't really a divide by Q, and I guess that was probably because it had the same distribution as the particles were distributed the same way as the state, so that wouldn't need to be done. But I wasn't clear about how that would happen in later states, or if the initial state basically took care of that.
The resolution on this is not fine enough that I can do an equation. I'm going to have to switch over to the board. Let me try again. For those that aren't watching this, or are going to eventually watch this on video, yeah, there's a cancellation that occurs, and that's why you haven't seen it. So that's a little bit better. P of y of n given x of n, and then if I remember, this has got to be p of x of n given x of n minus 1. And the whole thing is divided by the q, but in the car tracking example, and the most common choice that's used, you pick your q so that it's equal to p of x of n given x of n minus 1. And so what you end up with is this cancellation. These two terms cancel. And so you end up with a simpler weight update equation where it's equal to what it was, and then simply multiplied by the likelihood. And that's what you should have seen when you, for those of you that have studied my code, that's what should have been in there. Is that what you saw?
Yeah, that's what I saw, and I figured that was the case, but I tried modifying it to work with a distribution, a sampling distribution that was different from the state distribution. Basically, I just distributed the particles with a standard deviation that was like twice that of the process noise, just to see what would happen if there was a mismatch there.
When you do that, that cancellation doesn't occur, so you've got to have that ratio back in there. You've got to put those terms back in.
Mm-hmm. And you have to do that at every sample, or does it really only need to happen the first time, and then it would propagate with the particles?
No, you have to do that at every time for every particle. And what isn't included in here is all the particle indices. You know, all of these equations are for the ith particle. The observation is common to them, so you don't put it on the y, but it is for all of the x's. And again, I don't, with this particular app, I can't draw very finely, but you get the idea. There should be a little superscript I on all of the x's. So yeah, in that case, if you're doing that at every time step where you are, you said twice the standard deviations, rather than just moving them ahead in the predicted fashion, you're moving them ahead and then sort of blowing them apart further. And so this, you'd have to use a different ratio every time through, not just once. Good. Well, we'll be going through this some more, so hopefully there'll be some more questions about that as well. And let me just be honest about why. I've got on here begin importance densities, and I think there's a bug in the example at the end of those slides. I'm hoping we don't get that far, so I can fix it before we get to that. But I'll share with you a lot of my thinking. This is pretty tricky stuff, and I think I'm going to go out on a limb and argue that some of the thinking that you'll find in the literature that I've asked you to read that's on the website is mistaken, I think. And I think the thinking is just off. They get a nice theoretical result, and I think they started with wrong premises. And I want to discuss that with you. That's fairly complicated, and that'll be at the end of the lecture. What I want to go through slowly, though, for the sake of making sure you understand it, is the resampling. The resampling, we ended the last lecture of, here's a key thing, but I had to rush through it, and I want to go through that really slowly. if you can, in multiple dimensions, implement the particle filters that we finished with in the particle filtering slides, you're in good shape. And you probably have enough to even get going on the project and go all the way through the project. This is the 7th lecture of the term out of normally what would be 20 lectures. We went through all through Dead Week and didn't have a vacation. So we're less than halfway through. And by the end of today's lecture, you should have everything you need, really, to do the project. So this completes sort of the most important part. And everything else is not exactly gravy. I mean, there are improvements and there are important ideas in the things that we're talking about. But this is really the foundation and enough that you can actually use it and do tracking problems with. And it works really well. It may not be the most efficient. It may not be the best way to do it, but it's a good sort of reliable way that works well and is the most common way. So for that reason as well. And then just a reminder, again, I don't know how you felt about how useful last Wednesday was, but that was, for me, I get a lot out of that, and I'm looking forward to another session like that, where it may even be the entire lecture is spent on another 3 randomly selected homework presentations. So we'll be doing that again on Wednesday, and the numbers seem to continue to be dwindling, so that means the odds are increased that you'll be presenting on Wednesday, so be prepared, expect it.